Hello everyone and welcome to today's video on clustering, one of the most important techniques in data analysis. Today we are going to focus on k-mean clustering, a powerful algorithm for grouping similar data points together. We will cover how it works, its application, and how to implement it using Python. So let's dive into it. So what exactly is clustering? Clustering is grouping similar data. Clustering is a method of grouping similar data points based on shared features. Imagine you are sorting objects into categories based on their color, shape, and size. It helps us to identify patterns, reveal insights, and understand the structure of our data more clearly. Unsupervised learning. Clustering is a part of unsupervised learning, meaning we don't provide labels or predefined categories. The category discovers the group on its own by analyzing the similarities and difference within the data. Now let's zoom into K-mean clustering, one of the most popular clustering algorithms. K-mean is an interactive algorithm that drives data into k distinct clusters. It starts by random choosing k centroids, which represent the center of each cluster. The algorithm then assigns each data point to nearest centroids. Once all points are assigned, the centroids are recalculated based on the assigned points. And the process repeats until the centroids stabilize. This is known as convergence. Next in we have assumptions and limitations of k-mean. However, k-mean does not have some assumptions and limitations. Spiral clusters known key. K-mean assumes that clusters are spherical and well separated, and it requires you to know the number of clusters beforehand. Limitations are outliers, non-spherical clusters. It also has limitations. For example, k-mean can be sensitive to outliers and might struggle with the non-spherical clusters or overlapping data. Additionally, when dealing with high-dimensional datasets, k-mean can face the course of time. Now we have the preprocessing data for k-means. Before applying k-means, we need to preprocess the data to make sure it is ready for analysis. Data cleaning. Start by cleaning the data, remove irrelevant features, handle missing values, and deal with outliers to ensure the data is accurate and complete. Feature scaling. Feature scaling is a crucial key mean is sensitive to the scale of features, so we need to standardize the normal or normalize them so that no single feature dominates the process. Data transformation. Sometimes applying transformation like log or power transformations can make the cluster more distinct and improve results. Next, we have select the optimal number of clusters. One key challenge with k-mean is selecting the optimal number of clusters. Key. There are two popular methods to help this with. Elbow method. The first we have the elbow method. This improves calculating the within cluster sum of squares. WCSS. For different values of key, the optimal number of cluster is where the WCSS starts to level off. This is the elbow in the plot. Next, we have the Silhouette's score, which measures how similar each data point is to its own clusters compared to other clusters. A high score means better defined clusters. Next, in we have implementing k-mean clusters in Python. Let's jump into some Python code. So let's see implementation of k-means clusters. Step one: import libraries. First, we have to necessarily import libraries like scikit-learn for k-mean and pandas for data manipulation. Step 2. Load and preprocess data. Next, load your data using pandas, clean it, and scale it using standard scale or min-max scaler from scikit-learn. Step 3. Initiate and train model. Now create the k-mean model and fit it to your data. You are specifying the number of clusters k and other parameters. Step 4. Predict clusters. After training, use predict method to assign labels to your data point. Next, we have evaluation cluster quality. After clustering, it is very important to evaluate how well your model performs. We can use metrics like Sillihood's score, the Clancy-Harbors index, and the Davids-Bordin index to measure the quality of clusters. Higher values generally indicate better defined clusters. Next, we have visualization cluster result. Visualization is a key in clustering as it helps us better understand the results. Use scalar plots to visualize your clusters. Plot your data points and color them according to their cluster they belong to. You can even use 3D scatter plots if your data has three features. Next, we have the real world applications of gaming. So, what are the real world applications of gaming? Customer segmentation is a classical example. Businesses use gaming to group customer based on buying behavior or demography. Image compression. Gaming is also used in image compression, reducing the size of image while preserving important features. In document categorization, gaming groups similarly document together based on their contents. And it is used for the anomaly detection, where it helps identify unusual patterns in data like fraud detection. Let's sum up it. K-mean is a powerful clustering algorithm that can help you group similar data points and discover hidden patterns. With proper preprocessing, the right selection of K, and throughout evolution, K-mean can be essential tool for any data analyst project. The key takeaways are: remember, K-mean works best for spherical, well-separated clusters, but it has limitations when dealing with complex or high-dimensional data. That's all for the video. Thank you for watching and feel free to drop your questions or thoughts in the comment below. Happy clustering!